All right. Hello. Welcome to this video. So my name is Harley. I used to be a computer science teacher. I taught CSA for exactly 1 year, but I've done a lot of intro to computer science teaching, etc. So this is going to be I am YOLOing it, so to speak, which is that I want to do one take, review as much of AP Computer Science A as I can in one long YouTube video that hopefully I'll be able to add chapters and you can go through and skip through stuff as you need to. So enough for the intro. Let's dive right in. So Hello World is where you started. That was Unit 1. So with this, I've got a bunch of slides, and I'll share them in the YouTube description. Got a bunch of slides. I've got a multiple choice test. We might go through that if we have time in this video, or we'll go through it in another video. But from here, we're just going to dive in. I'm going to go unit through unit. We'll pull up the code editor if we need to test some stuff out as we're going. Okay, so you might get a question on this in the exam. Don't forget this. You learned it in September or October. But system.out.println versus system.out.print, you're going to get that multiple choice question where, oh, that was a print, not a print line, and you're going to have to make sure that you remember what that's all about. So if I say system.out.print and then system.out.print, they're both going to show up on the same line. If I change the first one to a print line, they'll show up on two different lines. It's kind of all you need to know about that. And you can put, remember, you can put anything in between those parentheses. It can be a string, it can be a number, etc. Cool. This is a slide. So a lot of these slides I went off of CS Awesome, which is a great curriculum. I can link that as well in the YouTube description if you're looking for more notes, more practice, more multiple choice. But syntax error means you messed up how things are typed. And on any of these, I'm not going to read the whole slide, so just pause the slide and you can go from there. Logic error means your code doesn't do what you're supposed to do. Debugging is fixing stuff. We've got the / comments, and then we've got the big comments. Your teacher probably makes you put the big comments at the top of your programs. But when you do this, right, when you put a big comment at the top of your program, it does absolutely nothing to how your program works. And so make sure, multiple choice questions are going to include comments that say some stuff. And then, depending on the situation, it might be useful to add a couple comments in your FRQs. String literal is the fancy word for the stuff inside the quotes. Unit 1 is going to be a lot faster than the other units, by the way. The main method, when you are in any code editor and you press the play button or run, or it's a VS Code and there's a little button, or it's Eclipse or whatever, it's always going to run a method called main. It has to be public static void main. You guys get that. A lot of times, they're not going to actually make you write a main on the test, but you know that from when you've been coding all year that it's always, the class is called, well, the class just has to have the same name as the file, and then any class that you have, if you want to run code, it's called the runner class, right? It's public static void main, and then it takes in the args here. Okie dokie. All right, so variables, you guys get this, right? You've been doing variables all year. But remember that variables have three parts, right? They have the type that comes first, then they have the name, they have a single equal sign, which means this variable will be assigned this value, and then the value on the right-hand side has to match the type of the variable. So you can't, right? You can't do int x equals, in quotes, 7. We'll get a compiler error, right? String cannot be converted into int, exactly. So we have to do this. And then we can take one of these print lines and we can print out, we can use the plus sign, right, and print out the value of a variable. You guys get that, but variables are super important. They're going to happen all over the test. And variables declaration is here. You can do the declaration and the assignment to the variable on two separate lines, and it'll work just the same. Bunch of examples of variables. The common types that you need to remember are string, int, double, and then in like chapter 6, 7, we'll get into arrays and array lists and instances of classes and all this sort of stuff. Cool. Yep, string, int, double, boolean, right? So the difference between, and booleans, right? Booleans are true and false. So difference between an int and a double is, do you need a whole number or a decimal number? This might come up in an FRQ where, in the FRQ, they say that the thing might have a decimal. Make sure that it's a double, not an int. Don't get caught on that. Assignment statements, that's just when you change a value of a variable. I don't know if you're ever going to get a question about the final keyword, but if I do final int x, I will get an error. Maybe I have to declare it outside the class. Final static. This is me coding live. Okay, cool. So here's the error. Cannot assign a value to a final variable x. You see that on line 11. Cool. So this will not work. You cannot change the value of pi. It's kind of a good mnemonic for remembering it. Concatenation is the fancy name for the plus sign thing that we did right here. Yeah, nothing crazy. Cool. Expressions. So I just like that people know the word expression. Whenever you're like adding or multiplying stuff, it's the same thing as for math class. So I always like to, with my students, talk about PEMDAS. Like PEMDAS still applies. When you do 2 times 3 plus 5, it's not some mystery thing, and make sure you don't screw this up. You do 3 plus 5 first. So 2 times 3 plus 5 is equal to 16. PEMDAS does apply, and PEMDAS, the fancy word for it, is operator precedence. Cool. So I have this big list here of operators. And again, any like table in here that looks good, credit to CS Awesome where credit to CS Awesome is due. Sometimes I explicitly call it out. Sometimes I don't. Sometimes I made these slides years ago. I don't remember, but shout out to CS Awesome. So we've got add, minus, multiply, divide. Are these things equal? Are these things not equal? And then modulo. Cool. So do practice this. When I had my students in class, we actually did Mad Minute style, like do 60 of these. So say whatever you will about ChatGPT, but ChatGPT is really good at making you a test. So what you can do is you can make yourself a little test where you add a bunch of system.out.println what's 7 mod 5, and everybody in the comments section, you should shout out that the answer is 2. Oh, I gotta get rid of this final thing. Yeah, the answer to 7 mod 5 is 2. So what you could do is you could copy paste a bajillion of these lines in your code editor of choice and be like, well, what's 5 mod 7? And in the comments, you should say that the answer is 5. And you're gonna need to do this. There are gonna be a few multiple choice questions about mod. Cool. You guys know your compound assignment statements. So we can always do x plus equals 2. What's going to get printed out here? The thing that's going to be printed out here is going to be 9, right? Forgot my semicolon. I think you're allowed to forget your semicolons and FRQs, by the way. And then in any expression, right, you can always use a variable in the expression instead of just numbers. So 9 mod 5 is 4, 9 mod 7 is 2. And mod, right, is the result of the remainder when you divide the first number by the second number and you round down. And then it's good to know that division rounding down is what happens. So this will catch you on a single multiple choice question at least. So 4 divided by 2, that's 2, that's easy. 5 divided by 2 is 2 if they're both ints. And then if one of them's a float, it'll stop rounding. It'll give you the decimal answers. Or not a float, sorry. Float is a Java data type. You'll typically see double. Sometimes I say float and double at the same time. If one of them's a decimal number, it'll stop rounding. Compound assignment, casting. Okay, I'm not going to go over this in detail because it's going to take me about 10 minutes to go through the rules. But casting is when you put the name of a type in parentheses in front of a value, and it changes that value's type if it's possible to do so. So you really only ever do casting with numbers. And so in this case, go into your code editor of choice, type a bunch of these, and see what happens. But let's test this one, see if I'm not lying. Let's put it in the code editor. Double answer equals this, system.out.println answer. 2.5, cool. And if we don't do this, it should be 2.0. Okay, so that's exactly the point of casting. This is like 95% of the time you're going to see casting. This is what you're going to see, is casting something to a double when you do a division. Yeah, data type ranges, you can overflow an integer if you want. That means that you run out of space and you go past 2 billion to negative 2 billion. So it's not going to happen, but you know, good to know about. And then at the end of these, I did legit, shout out to CS Awesome, I did legitimately copy paste their vocab section, which is why you can tell the formatting is off. So if you want some vocab words, those will be in the slides. And again, this will be linked in the comments. Okay, so I'm gonna take a quick pause here and then we're gonna move on to Unit 2. All right, we're back. I'm not doing it in one big tape. I'm taking breaks between chapters. But here we are, Unit 2. Unit 2 is really important, and it is harder than Unit 1. So we'll go there. So effectively, what is a class? What are objects? Classes are how in Java you define new types of data. So using a class, you can combine multiple pieces of data and model. You can create a model, a simulation of something that exists in the real world. So a lot of times in AP Java or in using Java in the real world, you're going to say you have a person class or a customer class or a car class or a dog. In real programming, you do other stuff that isn't just that. But those are realistic examples. People have multiple attributes that you can use to describe them, like their name, their age, their height, etc. And in order to describe a person, you need multiple pieces of data. So when you create a class in Java, you're saying, how do I combine the data? What actions can they do? What can I do? What can a person do inside of code, etc. And the way that you know that you've defined a new type is that we're declaring new variables here. I used to go by Mr. Meyer in class. So this person class that we've defined goes in the same spot as int or string or double. So we've defined a new type. This is the same variable name as always. And then we do this new person thing. And so we'll talk about that in a little bit. So Mr. Meyer or Serena Williams or former President Joe Biden, these are all objects. So objects are just words for a variable that has the type of the class that you're working with. And so objects, we're going to call it an instance of a class. Lots of vocab here, but you're familiar with this stuff. The goal of this video is to kind of remind you of what's going on and kind of just refresh your memory, think about how these things are going to work when it comes time for you to sit down for the exam. Cool. So yeah, that's it. And so what happens though, just FYI, so in code, right, you need to think about two separate things going on. There's person.java, and we're going to fill this up out in a little bit. And then there's main.java. You utilize your objects to make your main.java better. So you create classes so that you can do fancier stuff in your main. And then you can so you have classes that are using classes that are using classes, and chapter 9 or something, it's inheritance, and there's all sorts of crazy stuff. But for now, we can think about it. You have a class and you have a main. And one of the things that I used to like to say, just to get your head around what a class is, imagine a video game company with two people. There's the person who, I'm not going to use the word human being. There's an employee at the video game company who figures out what the characters do and all of the stuff and how to put them on the screen. And then there's the level designer, the human being, the employee of the game company, who is figuring out how the levels work and what's supposed to happen and where people move and where the characters move and all that kind of stuff. Two separate people writing two separate pieces of code. And they could each write their code in different files here, and the company would work smoothly. And that's really actually why they invented classes, FYI, to make it easier to split up the work at a big software company. Okay. Instance variables and methods. So instance variables are, these are nouns, right? I'm not an English teacher. Your name is a noun. That's a thing. Your birthday is a thing. Okay, these are nouns. So instance variables are nouns. Methods are verbs. That's how you think about it. So instance variables are, or they're attributes of a person. And then the methods are what the person can do. Cool. I'm going to read this piece of code out loud, and boy, oh boy, it's difficult. But if you can understand this sentence, you are in a really good spot for understanding classes. This line of code declares a variable called Joe Biden. Joe Biden is initialized with a new instance of the person class, which is created by calling the constructor. Oh boy, that's a lot of words. But pause the video, read that 100 times, and see if you can finally make sense of it. So what do we do? What is a constructor? A constructor is a piece of code that allows us to set up some initial attributes for the class that we're working about. So, these are things that are set up. So you can imagine a person enters the world and these are the attributes of them. So we need to have this. And anyone know how old Serena Williams is? No idea. She's probably like 40. Okay, so this code is going to run. This code's not going to do anything. Oh, and then we need to, so when you're making your class, I haven't typed Java code in a while, but you need to declare your instance variables up at the top, and then you define them with your constructor here. So my code now compiles. Excellent. And now I can system.out.print line Mr. Meyer.name, and we will receive Charlie. So instance variables, the way that you access them in the most simple form, it gets fancier later, but the way you can access a instance variable in the simplest form is by just using this dot notation. Now, implicitly what I did is I called these public. So public instance variables are ones that anyone can access using, I'm switching to main Java, anyone can access using this dot syntax. And then if we change it to private, that means you can't access it using the dot syntax. So going to main.java. So this line's gonna work fine, this line's not gonna work fine, and let's check that out. Age has private access in person, okay? So that code doesn't work. Only the code where the instance variable is declared public can we access it. And let me move myself a little bit. So the signature is that whole first line. So going back to the slides here, the combination of arguments and whether it's public, private, the name of the method, those are all called the signature of a method. So a constructor is a method. It's a thing you can do with a class. You're creating a new instance of the class. And then this list of things here, the variables that are passed to the class are not variables, but you call them parameters. There are a lot of vocab in this chapter, but these are the formal parameters of this method. Lots and lots of vocab. So yeah, describing the difference between formal and actual parameters. So these are the formal parameters. And the really important thing to remember is that there's a string and then there's an int. So whenever you go to use the method, you have to have a string and then you have to have an int. So the order and type of the formal parameters has to match whenever you're using the method. The order and type of the actual parameters has to match. So important. So there's probably, I don't know how many questions there is on the exam, 40, 45, 50. On that exam, there's going to be 2 or 3 of these where it's just like, the whole point of the question is just matching up the formal and actual parameters and making sure that they didn't get mixed up. It's going to be like, which one of these errors or doesn't error, and some of the formal and actual parameters are going to get mixed up. Cool. So calling methods, as we discussed, as we haven't discussed actually, we've only discussed now doing the constructor and the instance variables. Now we have all of these different things that you might, methods you might define on a class. And yeah, so a person could say hi or eat lunch or play tennis. In order for these methods to work, we have to define them in the class. Cool. So, in here, we'll get more into defining more methods in a second. Okay, cool. So here is a more complete example of the class where we define a actual method. So we can go in here and we can do Mr. Meyer.say hi. We can do Serena Williams.say hi. Okay, so we have 2 objects defined. So let's just use a little vocab here. We've defined the Mr. Meyer object using the person constructor. Charlie and 29 are the actual parameters, and they match the formal parameters of the person constructor. we've now constructed a second object called Serena Williams. Serena Williams, in order to create that object, that instance of the person class, we use the person constructor and we pass the actual parameters, the string Serena and the number 40, because the formal parameters were string and number of the constructor. Now we have these variables in our code, these objects of type person, and so with them we can call the methods. We can call the method that's defined on the class called sayHi. And that sayHi method, the whole point of methods, and so the whole point of classes, is that the methods can access the instance variables. Whew. So a person is like, almost a way to think about it is a person here is a super variable. It has two different types of things going on. So I could do this, and my age is age. So I've now changed the definition of the sayHi method, and now I can make these both private, and this is more how you'd see a class defined in the APCSA exam. The instance variables will be private. In order to access the data inside of those instance variables, you'll use some sort of methods. Whew. Okay. Furthermore, okay, methods that return values. So what are the return types? Let me see if I have a slide here that works well. Okay, I'm gonna have to reduce this. So I almost want to use this slide to go over this little section here. So this is a really critical thing to understand is this slide. I made this slide, so credit to me for making it. But boy, oh boy, do you need to know this. So there are three types of methods that you can define, that you can write code for in a class. The constructor, so you can read the slide, but the constructor is for making the object. A void method is for basically printing stuff. There's a million reasons why you might want to use a void method in real life. In the context of the APCSA exam, 99 times out of 100, the purpose of a void method is going to be to print stuff. Is that true? That's not true. Half the time it's going to be about printing stuff. Half the time it's going to be about changing the value of an instance variable. We'll get there later. But then there are non-void functions. Oh my gosh, how confusing is this? The non-void function. A function that isn't void can return, do we have any examples? Okay. Whew. Tough stuff. So what is an example of a not void method? So when I say non-void method, I mean the type defined on the instance method, on the method, is something other than the word void. So here is a double. So we've changed the person class where I have a height in feet. So my height in feet is something. My height in meters, we can perform some calculation in order to get my height in meters divided by about 3.1. This return thing, going back to here, this could be p.getHeight in meters, you get it. This here is an expression. So what happens is Java goes to run this line of code. It is like, I'm going to print something. What am I going to print? I'm going to print the return value of this method. So then it goes, it finds that method, it evaluates the code for that method. Whatever's returned, you can kind of think if you were going to evaluate an expression in math class, you would cross this out, you would put the return value there, and then you go and print that thing. Jeez Louise, is that complicated. So I will define a method here. Public int get age. Return in dog years. Okay, wait, so my age in dog years. How old am I in dog years? We're gonna have to cut out this silence. If I was 29 and I was a dog, in dog years, I'd be 210 years old. So we're going to see that in just a second here. We're going to system.out.print line Mr. Meyer get age in dog years. We're going to put a semicolon at the end. 203, I guess I was off by a little bit. But do you get what I'm saying? So this, just to clarify, this get age in dog years method does not print anything. So if I have this code here, let's simplify this. 2 lines of code. We declare my variable, we call this method. Do you see I press play? I can press play 100 times. Absolutely nothing's going to happen. I have to print this out because it's returning a value. I can put the number 203 on a line of code. Did you know that? No, I can't. Never mind. Whatever. But it would be like putting the number 203 on a line of code and expecting something to happen. That's crazy. So you have to put it in a print statement in order for the value of a non-void method to show up on the screen. Okay, moving slightly along. This got covered in Unit 2. I'm not sure why, but all your string methods. Strings are instances of a class. They have a bajillion methods. I'm not going to go here. So I copied these from, used to call it the textbook, CS Awesome. I copied this from CS Awesome. A lot of stuff going on with your strings. So do I need to go over these all right now? I guess the most important one I would go over is, you know what, we're going to go over these methods later on in some other context, probably in the if statements context. So you're going to need to know all these. They also, I'm 99% sure, are on the reference sheet. So you want to know them and you want to have memorized them. But if you forget some minor thing about them, they'll be on the reference sheet. Wrapper classes are basically stupid. You'll go over them later. Okay, the math class and static methods. There is a class in Java called math. Just FYI. Double my double equals that system.out.print line my double. So you can call this, and it gives you a random number every time. That's crazy. But it's actually useful. You end up using it a lot. Like, I don't know, a few years ago, there was a FRQ about simulating a lottery or something, and you needed to use the random class. They also have stuff for taking powers of stuff, getting the square root, all that. Here's the reference sheet that I copied from CS Awesome. Here's a bunch of vocab. So again, like, what are the purpose of these videos? It's to refresh your brain, jog your memory. I'm not going over every last little thing, otherwise this would be like 10 hours long. So we're trying to get you the basics. This chapter was 20 minutes long, and we'll see how the rest of them go. It's been fun so far. We've got 8 more chapters to go, and I've got about 2 hours left in my morning before I need to go do something else. So let's keep it rolling. All right, we're back. Unit 3, if statements. Let's rock and roll. Let's do it. Okay, so in order to get if statements working, we need to have expressions that return Booleans. What do I mean by if statements? You know what if statements are, but just FYI, if statement is saying, if one thing is true, do this. If it's not true, do the other thing. And then a bajillion variations of that. So we need some idea of determining if expressions are true or false. So this was covered back in the operators in Unit 1, but I kind of skipped over it. Now we actually need to talk about it. So I'm going to make this nice and big. The equals operator, right? Do not screw up on your FRQ, a single equal sign and a double equal sign. You know that the double equal sign is for testing equality. So 2 equals 2, 4 plus 5 equals 9, blah, 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 blah. You can't do equals on classes. So you know that. Your teacher has said it to you about 100 times. But yeah, equals doesn't work on 2 different instances of classes. It just determines if the objects are literally the exact same. So my name equals my name. My name equals. So my name equals my name is true. My name equals my name again is not true, even though they have the same value. That's just a thing. And then exclamation point equal sign operator is for not equals. Relational operators is the fancy word for all of these guys, less than or equal to, greater than or equal to. You get it. You kind of need to know the word block of code just because stuff inside of curly braces, you're going to get a lot of curly braces here in the if statement chapter. And you do blocks. I'm just like moving myself around because I don't know where the slide's going to get cut off by my stupid bubble. So I'm moving all around, but now I think I'm safe. Cool. So if statements, the one thing about if statements, I'm going to go kind of fast because I feel like if statements are like the easiest thing. They're not that easy, but like you got to be careful and they get complicated, but like everybody gets what an if statement is, which is nice. Classes are so much more abstract. So if statements, if some condition, then you put a block of code that happens if the condition was true. Here's my arrow key. So I declared a person's age as 27. If the person's age is greater than 24, then we print this thing out. You can legally rent a car in the United States. You have to be 24 to legally rent a car, I think. And so what happens, just zooming in slowly, I'm going to do this one time and then we're going to not do it as many times. If this expression. So Java sees an if statement. In the parentheses, it sees an expression. This is the expression. In order to evaluate the expression to determine whether it's true or false, we need to substitute in the value of the variables. Then we need to do the comparison and determine if it's true or false. Whew, that was a lot of steps, but that's what happens every single time. So we substitute, but then you start being able to do it in your head really fast. So 27 is greater than 24, you can legally rent a car. If else, what gets complicated about if statements is that there are so many variations, but you got the slides. Again, they'll be linked in the YouTube comments, so you can go through these slowly. But if else, nothing to say here. Nested if statements is one way to do it. So in your block of code, you can have an if statement on the outside, and then if that's true, we can continue running code, and that code can also include an if statement. So here's your example, and you can do nested ifs and if else's, and you can combine them in literally infinite ways. So we have their age and their money, and whether they can legally rent the car or afford it. Else if, so we're going to check this condition, and then we're going to check this condition, see what our example is. If you're over 24, you can legally rent a car. If you're younger than 24, but you're older than 16, I don't know. In most states, it's 16. If you're over 16, you can get a learner's permit. This actually is probably, now that I'm looking at this slide, probably incorrect. This should be greater than or equals to. So AP Java, AP CSA tip, they're going to hit you with the greater than or equal sign like 3 or 4 times on that test. So be ready to be careful. Greater than equal, it matters. It really matters. And if you're a 16-year-old, it matters if you can get a learner's permit or not. So just saying. Okay, you can do if, else if, and then else. If you're greater than 24, if you're greater than 16, if you're under 16, don't even get near a car. I was proud of these slides. I thought they were kind of funny. I made these ones by myself. Okay, Boolean expressions. I'm not going to go over this all day, but you need to know this, and you need to really, 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 really know it. And I've even color-coded this. I did a good job on this slide, I believe. And evaluates to true if both sides are true, or evaluates to true if either side is true. Not evaluates to true if the expression is false. Neat. And these are pretty logically, they make sense, right? If you are over 24 and you have over $100, you can legally rent a car and can pay for it. If you're under 13 or... Did I get this wrong too? Yeah, if you're under 13 or over 18, you're probably not in high school. So let's just logic that out. In the event that you're under 13, you're definitely a little kid, you're not in high school. In the event that you're over 18, it's very likely that you graduated. Maybe we could fudge that around a little bit. Some 19-year-olds in high school. Okay, I'm not going to go over this. De Morgan's laws. This is me. So I have some editorials in here about things that I believe about the AP CSA exam, and you can treat my editorial with a grain of salt, which means doubt me maybe a little bit. Um, I'm not going over this. Okay, how do you compare objects, so instances of classes? You need to use the dot equals method. So if you've got strings, good is using the equal sign. For numbers, good is using double equals, or sorry, the equals method. Jeez. Good with strings is using the equals method. Good with numbers is using equals equals. Bad with strings is using equals equals. Bad with numbers is using dot equals. This won't work either. You want proof? This will not compile. Int cannot be dereferenced. That's an interesting way of saying that you can't do it. Okay, so you can't, that's actually bad as well. So I don't know who messes that up, but you can't do it. Okay, and so that's the thing. Unit 3, actually the shortest one of these videos so far because I just think it's pretty logical. Like, you get it, you get what if statements are. They're going to get complicated, and like what matters is your ability to combine these things and do them on the test day, not mess up your ands and ors, not mess up your dot equals and the equals equals sign. Those are the real tricks. The actual logic of the if statements, like if it's a multiple choice question, you just gotta be careful. You're not gonna like forget what an if statement means. It's just they could have so many of them that it gets complicated. But the actual if statement itself, I think, makes a ton of sense. So we should be confident about that. But when it comes time for the exam, be tricky. And on this channel, maybe we'll do some multiple choice practice as well. Okay, that's it for Unit 3. I'm going to take a 2-second break and then I'll be back in a second. All right, we're back. I'm going to put myself over here and zoom it in. Unit 4. Unit 4 is the loops one. The loops matter big time. Am I going to dive into every last little detail of loops? No, I'm not, but we need to go over all of the different types so that you know what you need to study. Don't know why I put while loops first, but a while loop is the same thing as an if statement, except that the code keeps happening. Think about that for a second. While loop is the same thing as an if statement, except that the code happens over and over again, and over and over and over again. So that's what a while loop is. Like, don't get it too complicated. Don't think about it differently. It's just an if statement, but it's an if statement, and then it checks again. And then it does the code, and it checks again. And it does the code, and it checks again. And it does the code, and it checks again. That's all it is. So, how do you make it, though? Like, checks the thing, and then goes again, checks the thing, goes again, checks the thing, goes again, checks the thing, goes again. That's going to happen forever unless the thing that you're checking, some value in it is changing. Just pausing for effect there. It's not that complicated of a concept. So you're good. You gotta change one of the variables that's part of your comparison here has gotta change. Otherwise, you're gonna have an infinite loop. So here we say that your age is 0, and then we do person's age plus plus. This is your big pattern. This is how while loops always work. You declare a variable, you do the while loop with some comparison about that variable, and then inside of the while loop, you change that variable. You got to change the variable inside the while loop, otherwise it's going to happen forever. Okay, there are while loops. Mission accomplished. For loops. For loops are the same thing as while loops, but you do it all in one little, like for loops are literally the same thing. They're literally the exact same thing as a while loop, but you combine all of this stuff into one statement. So let's look at a while loop here, a practical example of a while loop. We initialize a variable, we do a comparison, we change the variable. A for loop, we initialize a variable, we have some condition, and we change the variable. That's all a for loop is. So they're the same. They're the exact same. They're the exact same. They're the exact same. So don't get confused. It's all good. It's all good. So here it is. We just rearrange the stuff, basically. And then you can get complicated and you can change up you can have as much code in here as you want, including if statements or whatever. But, you just have to imagine this thing happening over and over and over again. So when Java shows up to this line of code, I'm going to make it bigger. When Java shows up to this line of code, it declares the variable, it does the comparison, and then here's the tricky thing. Like, in your brain, copy paste, I wish I had some way to do it, like an iPad pencil or something, but copy paste that line of code and put it at the last line of the loop. That's the complicated thing. So that's what screws people up. But if you remember this is what I had. I had the change statement as thing in the loop. So that's that. So let's take this code and actually run it just so we know what's up. So here's my main. I'm going to get my indenting right. Okay, get my indents right, and I'm going to run this code. You are 0, 1, 2, 3, 4, 5, 25. You can rent a car. You are 26. You can rent a car. I think this should be a greater than or equal to sign. But that's it. Do you want to see me write this exact same code as a while loop? I'm going to be cutting and pasting here. This is what's crazy. So I cut the initialization statement here. I'm going to change this to while. I have this in here. And then I'm going to take my changed statement. I'm going to put it at the bottom. I'm going to clean up my syntax. And I bet my life that this will do the exact same thing. Holy guacamole, it did the same thing. Wow, that made me sound like an idiot. But you get it. They're the exact same. So I can undo this code. For loop to while loop. That's it. They're the same. They're the exact same. They're the exact same. Okay, won't emphasize that any further. Loops and strings. Let's check this out. This is a very common pattern that you're going to need to know how to do. Let me get my indenting right. So this is going to print the alphabet, just FYI. No, it's not. Cannot find symbol. Oh, this should be my string. System.out.print line letter. Here's some better code for you. That printed the alphabet on different lines. And we could also print I is. Oh. Syntax error. Oh my gosh. What did I do? Do I need to cut this out? No suitable method found for system.out.println. Can you guys help me find this? Do I gotta cut this out? Oh, I did a comma, not a plus. That's debugging there. And then let's do another space. Cool. So this is just reviewing. That's real life debugging there. It's 8:51 in the morning, so maybe that's why I did it wrong. Now, here are some conventions about loops. You're almost always going to start at 0. You're almost always, with a string, going to go I less than the length of the string. Like, you can go and do all the math and determine why this works, but at the end of the day, when it comes time for the test, let's just memorize it. Start at 0, I less than string.length, I plus plus. To get each letter, you do the substring from I to I plus 1. Just getting my spacing right. And then here's your output. So you go in, you take this code, put it in your code editor of choice. It's going to do this exact thing. So that's that. Sorry, that took a little bit of time. But memorize this loop. This is super common. Okay, nested for loops. You can put a loop inside of a loop. Nothing gets crazy. It's still the same logic. You could still turn the for loops into while loops. You could still do all of the logic. All of the checking is the same. It's just And let's just put this in here. Let's put this in the code editor so that we can test it out. Let's get this in here. Can't type. Okay, so here's what happens. I is 0 a bunch of times, and then we go through all of the j's. Then we change I to be equal to 1, we go through all of the j's. I is equal to 2, we go through all of the j's. Here is something that will happen on the AP exam. They will give you, we can get rid of this. They will give you this snippet of code, and they will say, how many print statements will occur given this code segment, when this code segment is executed, or whatever it says. 100. So this happens 10 times. This happens 10 times. So overall, there's 200 things printed. Here, there's going to be 200 things printed, 10 times 20. We could do 5 times 200, and there would be 1,000 things printed. You multiply the number of times that 2 things printed. So there's a lot of lines there. There's 2,000 of them. You guys get it. We're going to go through nested for loops more in a later chapter, but that's kind of it. So this is the basics of loops. So how do they get you? What's the point? How are they gonna trick you? Where are the test questions gonna come in? They're gonna come in with the less than or equal signs. They're gonna give you while loops and tell you to turn them into for loops, or for loops and turn them into while loops, or say which one does what, and they're gonna get you with the zeros and the less than or equal signs. And you need to memorize this string thing. And that's how loops are gonna work for the basics of them with just regular numbers. In a later chapter, we're going to get into arrays and array lists, and that's where it gets a little bit more complicated. But for now, basics of loops, they're really not that bad. They're just if statements that happen over and over again. And if you ever get stuck, a for loop is just the same thing as a while loop with the stuff moved around. You saw me do that coding live, and you know that it worked. So that's it for loops right now. Take a quick break, and then we'll be back for Unit 5. We are back. All right, Unit 5, more stuff about classes. So what's crazy is that Unit 5 and Unit 2 are like the same thing. I don't know why they're even 2 different units, but it is what it is. So when you make a class, right, you're defining a new data type that has attributes and those are instance variables, and then behaviors, which are methods. A single instance of a class is called an object. Okay, so anatomy of a class. Wow, what a fancy title for a slide. You've got name of the class. You've got your instance variables, and you got your constructor. That's awesome. You use your constructor to make an instance of a class. Yep. Yeah. Fun fact, why do you always name the parameters of the constructor something different than instance variables? Because otherwise Java will get confused. This isn't a knock-knock joke. Java will just get confused because you would be saying name equals name, and it wouldn't know. So you always name the parameters for the constructor something different. That font is wrong on that slide. Fonts right now. Okay. Anyways, public instance variables can be accessed by any code outside using this dot notation, or they can, if it's a method, they can be used by this notation. Private methods, instance variables can only be used inside of the class. There's a vocab word, encapsulation. I don't know why you need to know it, but that's, I guess, why you do it. There are like fancy reasons why you do this. There's like a fly in my house. I don't know why, but it's flying around in my face and it's driving me crazy. And I want to finish these videos. I'm gonna get it done, but the fly needs to die. No offense to the fly. The unit 4 is closed. Okay. So patterns. What's gonna happen when you're doing your classes? You do your getters and your setters. This is just how you do it in APCSA. Is this the perfect way to do it in the real world? It's kind of a common pattern in the real world too, but this is just the way that you do it. You have every instance variable, and then you got your public getters. The instance variables are private. You got your public getters and your public setters. I copied some of this vocab. Shout out CS Awesome. It's like the 11th time I've done that. Getters are technically called accessors. Setters are technically called mutators. I don't know why you would need to know those, but that's that. I also misspoke earlier, and I said that 99% of void methods just print something. That's not true. Do you see the word print on this page? No, you do not. All right, so nothing gets printed. A lot of void methods are setters because all they're doing is changing a variable. They're not printing anything. They're not returning anything. You can write comments in your classes, and you've probably been asked to by your teacher. Preconditions and postconditions. Preconditions and postconditions are really fancy comments. I'm not going to get into them right now. If you've been asked in the process of writing code for your class as a student to do preconditions and postconditions, that's awesome. I just personally never have focused on them. You can pause, read the slide. It's a thing that people do. A lot of code, just FYI, just a little aside, a lot of code is about style. Like, programmers in the real world have style guides, style things that they do, code, they like to write it in their own style. So some people love doing preconditions and postconditions. Me personally, it's not when I write code in the real world. Okay. When you're writing methods, again, this is like a lot of a rehash of Unit 2. So it's kind of good that we're doing it twice because it is very important. But every method needs a name, return type, and formal parameters. Void is a return type that means that the method won't return anything. Here are some examples. This is a method with no parameters that returns a string. This is a method with one parameter. It's void, doesn't return anything. This is a method that is void, no parameters, and the only purpose of it is to print something. Cool. Not dealing with that right now. Static variables and methods. That's a separate video, not dealing with that right now. Okay, scope stuff is kind of important, so I'm just reading the slide and thinking about it. So when you have an instance variable, you can use that variable literally anywhere in any of the code, in any of the methods in the class. If you have a formal parameter, where's an example of a formal parameter? If you have a formal parameter new name, this is a formal parameter, it can only be used within this method. And then if we went back to Unit 4, this int person's age is a block scoped variable, so it can only be used within this block. That it is important. The this keyword, are you going to use it? We're not going to go over the this keyword right now. You can always, I guess, just like, if we're in person.java, you can always do this. Haha. This code works the same. You can always refer to inside of the definition of a class, you can always refer to an instance variable or an instance method using this dot name, this dot age. And so you could do, I'm not getting into it, but you can. I don't want these to be like 6-hour-long videos. Cool. So here's the vocab copied from CS Awesome. Shout out CS Awesome. That's it. That's classes review. Now, I mean, what's the difference? Like when you were in class this year, what was the difference between Unit 2 and Unit 5? And in Unit 5, you became responsible for writing your own classes. And so if on a YouTube channel here we ever do any or practice like that or practice questions, the Unit 5 questions get to be more in depth. But in terms of the actual vocab and the actual concepts you need to know, it's basically the same. So this is a short section here, and we will get ourselves moving on to Unit 6. We're back. All right, Unit 6. Unit 6 is about arrays. Hooray for arrays. How about that? You can tell that I've been sitting here at my desk. It is, I started at like 8 o'clock and it's now like 9:15. So I have been basically doing this in one sitting. I've just been getting up and getting a glass of water in between chapters and making sure that the uploads are happening correctly. So arrays are how you store a list of data. It gets so confusing that there's even a thing called array list. We'll get into the differences between those two. I'm just fixing my hair. We'll get into the difference between those two in a second, but you use the brackets. You can do int bracket scores, string bracket names. That's how I always say it out loud. This is for making a variable that can store multiple pieces of data. So how do you initialize an array? How do you create an array? You do this syntax here. You can do this. Nobody does this. Everybody does this instead. So I'm going to do just the absolute most classic thing in the world. Let's just make sure. I'm going to do the most classic thing in the world just to skip to the punch here. Who cares about the person class for now? This is how you use an array. This is what happens. We're going to go over something else in a second, but would you look at that? You have a list of things, and how do you access all of the things in the list? You use a loop. So lists and loops always really go together. They're a powerful combination. So you 1,000,000% need to memorize the syntax and everything that's going on and fully understand exactly what this is all about. So rather than go over the slides for a second, I'm just going to go through this. We're declaring a variable of type array of string. So we use string bracket bracket. Variables that are arrays, it's very common practice to make them plural because that just makes sense. You do equal sign, you use the other type of bracket, you put the elements in the array that you want, and then you do a loop here. For int I equals 0, I less than animals.length I plus plus, string system.out.println animals bracket I. Okay, so what really happens here? I'm going to kind of animate this. Let me make my font size a little bit bigger. Okay, so what really happens? Java goes through here. For int I equals 0, I less than. First thing it does is evaluate this. Animals.length right now is 3. Okay, and then it's system.out.println animals bracket I. So I'm going to put a comment here. I is equal to 0. So what's animals bracket I? Well, that's animals bracket 0. What's animals bracket 0? It's the first thing in the list. So we're going to print out, first thing in the list is elephant. Okay, then we do our I plus plus. So now this is equal to 1. So animals bracket I, when we change this to 1, animals bracket I, that means animals bracket 1. We delete this, this is giraffe. Then we print giraffe. Great. Then we change I to equal to 2. We're doing animals bracket 2. That's aardvark. Excellent. Now, when we started the loop, it evaluated that animals.length, the number of things in this array, was 3. So it substituted in 3 here. And so when we do the plus plus again, and I is equal to 3, is 3 less than 3? Is 3 less than 3? Is 3 less than 3? No, it is not. So that's why we stop. Now, there's going to be a million multiple choice questions and variations of this. This loop right here is incorrect because this, I'm just going to write some comments here. Elephant is index 0. Giraffe is index 1. Aardvark is index 2. Absolutely nothing is index 3 or above or some negative thing. So you can't have, it's called an out of bounds error. You can't do, let me bring this, well, can I like zoom back in time here? Let me go back to what this used to look like. So close. Going back in time, going back in time, going back in time, going back in time. Okay, this is what it was. Okay. So, yeah, this is what we had with our original loop. Yeah, anything other than 0, 1, 2, this is index 0, elephant is index 0, giraffe is index 1, aardvark is index 2. Anything outside of that is a disaster, won't work. So you can't do less than or equal to. Let me do it. It's going to say index 3 out of bounds. Great. Nice work, team. Let's change this font size back. Okay. Index 3 is out of bounds. Let's start this at -1, just to be stupid. Index -1 out of bounds. Wow. Amazing. Okay, so that's kind of how it works. And let's just see if I was doing anything in the slides. Yep. Elephant, giraffe, aardvark. I even used the same thing. Very nice. Okay, so the index is what number in the array it is. The length is the number of elements in the array. Memorize the syntax. Memorize this, memorize it, memorize it, memorize it. You logically know what it is. You could maybe recreate it. Just memorize it. I equals 0, I less than animals.length. It's not less than or equal. This is a pattern. There's a million ways you could do this, but this is the pattern that's most common, so do it this way. You can do your loop in reverse. I would honestly also memorize this syntax. I'm going to copy paste it into my code editor. Shout out to PicCode. That is what this YouTube channel is, by the way. You're on the PicCode YouTube channel. Okay. And this is going to print aardvark, giraffe, elephant. Okay, so I'm not lying. Okay, enhanced for loops. Memorize this syntax. It's an easier way to access all the elements in an array. Let me get my stuff worked out here. So you do string animal bracket or colon animals also works. Okay, here are some things that you need to know about arrays, some algorithms. What is an algorithm? It's a series of steps to accomplish a goal. Here we've defined a series of steps to accomplish a goal. Here, what is our goal? Our goal is to print whether or not we found an item in the array of integers called items that is equal to 42. Trust me, this works. So you have a for loop with an if statement in it. Find the maximum, find the average, and a bunch of vocab. So these find an item, find the max, find the average. There are variations on a theme, but you're going to have an FRQ that probably goes over this, or a half dozen multiple choice questions that have variations on this theme. Go nuts. Please do memorize this. Please do memorize this, especially this average thing. I'm not going to go through it right now in great detail, but there you go. There are some code snippets that you can take a look at that you can memorize. I know you've done them in class, but just memorize them. It's for your benefit. Memorize them and understand them. Go through and make sure that you understand what's going on. But that's it for arrays. Trying to keep these short and sweet, and that's chapter 6 for you. All right, we're at Unit 7. Thank you for making it this far. Nice work, everybody. We're doing great stuff. Okay, Unit 7 review slides. So we just went over arrays. What's the easiest way to get everyone confused and overcomplicate everything is to do arrays right next to array lists. And I'm not going to deviate from how Java does it and how the APCSA exam does it. We're going to do arrays next to array lists. So there are two ways to do the same thing. Two ways to do the same thing. What is the fundamental difference between the two of them? Is that you can add things to array lists. Okay. So I almost just want to do, okay. First of all, you do this. You have to use the word array list and you have to add the types into these angle brackets here. So it's a different way to declare them. That's just how you do it. They have different methods. These should be on the reference sheet. Our array list methods on the CSA reference list. These are included on the quick reference list. Shout out to CS Awesome. That's what I'm talking about. CS Awesome rocks. So if you're like, this person in the video was very frustrating and I did not like listening to what he had to say, just go to CS Awesome. It's another great resource. I hope you didn't get basically an hour and 15 minutes into this video and then be like, I don't really like this guy. I'm going to go somewhere else. That'd be too bad. Anyways, so here are the methods. They are on the reference sheet and they kind of make sense. So let's just go through this example. I have an array list. I add cookies. I add apples. I want to access the thing at index 0 that prints cookies. What's the size? Array lists don't have lengths, they have sizes. But how many things are on my shopping list? 2 things on my shopping list. If I change, the first thing on my shopping list to carrots, imagine I had a piece of paper and I crossed out. This is what happens when you set stuff in arrays or array lists, by the way. I cross out the 0th thing, the first thing in the list, and I cross out cookies, and I add the word carrots. So now when I get thing 0, before when I got thing 0, I got cookies. Now when I get thing 0, I get carrots. All right, I can also remove something, and then the size decreases. Okay, not too crazy. This is really, 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 really an important table. And I think I made this one myself. So shout out to me for making this table. Memorize this, all right? If you were like, arrays made total sense to me. I love arrays, but I can't stand array lists. Just make some flashcards for this table. And the big difference, why do we have array lists instead of arrays? Array lists, you can add and remove stuff. You can't add and remove stuff for arrays. So someone asks you, hey, why did they ever even invent array lists? That's why. Okay, I'm not going to go through the whole code editor thing again because array lists work the same. But basically, use your mind and use your imagination and use the table here and swapping things out. And this is how things work. Now, here's another wrinkle, another reason or another thing that happens. On one of the FRQs and in some of the multiple choice questions, you're going to have array lists of objects. So array lists of instances of classes. So you're going to get this syntax where you get thing I in the array list, and then you also call a method on it. You could do this in 2 steps and create a variable for it, and then also call the method, but you can do this. The enhanced for loop looks a lot better for array lists. It's very nice. So all it does is go through all of the things in the cars list. It creates a little variable C for it and then does that. Boy, oh boy, am I not going to go through this right now in a quick YouTube video, but pause the video, convince yourself that this is correct, or find the bug in the code that I created. But yeah, the whole algorithm's the same. You go through all of this stuff, you find the minimum thing, and you return it. Here, to find the sum, so to add up all of the weights of all of the cars in your array list, you do a similar thing. You use plus equals. All of the algorithms, so an algorithm is a series of steps you use to accomplish a goal. If your goal is the same and you have an array list versus an array, your code is going to be very similar, but you're just going to have to use this table to kind of translate between the two of them. And then obviously things get a little bit more complex. Wow, okay, this is a good one. Array list algorithms. Find index of item with property. So pause this video, write this one down, type it into your favorite code editor. In all of these, I'm making an empty array list, and I'm assuming that you would say array list add new car to fill up the array list. But that's finding an item with an index. And then in the context of an hour-long video, am I going to go through why this is the case? No, I will not. If I ever make this YouTube channel a bigger thing with more videos, I will. But trust me, if you want to remove something from an array list with a specific property, and you want to not screw up all the indices, you need to go through the array list backwards. We can logic this out. If I had a whiteboard or an iPad pencil, I could convince you of that fact. If it's today's April 14th, 2025 APCSA exam date. The AP exam CSA. Computer Science A. Computer Science is on May 7th. So we don't have a ton of time. Just take my word for it, and yeah, you're going to need to go backwards to remove stuff. Okay, and then there's a bunch of vocab, shout out CS Awesome for the vocab list. The real thing is basically my strategy for this is understand how arrays understand how arrays work, and then use this table to translate your understanding, and then think about how with array lists you can add and remove stuff, and then memorize these different little algorithms. Okay, so that's all I got to say about array lists. We're getting close to the end of these videos. Nice. There's the fly. It keeps flying around. All right, we're back. Unit 8. Unit 8 is 2D arrays. So what's more confusing than having arrays and then array lists? Let's add in a third thing in a row, Unit 8, which is about 2D arrays. It's not that confusing. 2D arrays are arrays inside of arrays. So remember how we had, and this is going to come up in like 2 seconds. Remember how we had a for loop inside of a for loop? You can have an array inside of an array. And so that's all it is. This is how you declare them. I'm not going to go over the syntax too much. Here is a great diagram that I copy pasted from, or screenshotted from CS Awesome. Shout out to CS Awesome. This is a Java array of arrays. So another way of saying 2D array is array of arrays. Okay, so here you go. The number one thing that you will screw up, I'm reading this from the slide. The number one thing that you will screw up is rows and columns. A row is all of the stuff going left to right. A column is stuff going up and down. If you're confused, this was me, I didn't screenshot this from anything. I made this helpful table for you. I would memorize it. I would make sure that you really understand how that works. Okay, and so really, and then I use the Java syntax. So to access stuff in 2D arrays, you do bracket, bracket for the row index, and then bracket, bracket for the column index. So it's row first, column second. Come on, don't forget it. And then this is not always the case in real life that it's row first, column second. It's actually a convention. You can do it either way. 99% of the time, it's row first, column second. If you're ever given a choice, just do row first, column second. You're going to be agreeing with like 95% of humans in the world. Take a big sip of coffee. This was a stupid slide that I did as kind of a joke. When I did this lesson as a teacher, I just said row first, column second like a million times in a row. And again, it's not actually always true, but it's effectively true. Memorize this slide, you'll be feeling pretty good. Okay. Number of rows and columns. So if I have an array list of things, things.length is the number of rows, things bracket 0.length is the number of columns. Because this is the length of the first row. Oh my gosh, yeah. I mean, these words get so confusing. I just said that and then I got like absolutely terrified. But let's count, let's just do a little bit of basic counting. How many rows are there? 1 row, 2 rows, 3 rows. How many columns are there? 1, 2, 3, 4, 5, 6. That was absolutely terrifying for me because I was scared I was going to mess it up, but it's all good. It's all good. Getting values in a 2D array, row first, column second, you do 2 sets of brackets. You can still use variables, obviously, in your brackets. Rows outer, columns inner. This is a classic. Memorize it. Just memorize it. We use I, which we have always used for our loop variable. I is short for index. J is short for, trying to make a joke. I'll tell you why in a second. What's a funny J word? J is short for juice. No, J is the next letter in the alphabet. If you had a 3D array or a 3D loop, you would do I, J, K. Then you I, J, K, L, M, N, O, P, probably. You would keep going through the alphabet, but it usually, I've never seen it go past L. I've seen a 4 times loop, but if you're doing that in real life, something's gone wrong. Okay, you can do an enhanced for loop for 2D arrays if you want to. Here you go, find an item. I'm not going to go through this, but memorize this. You're essentially doing the same algorithm. An algorithm is a series of steps to accomplish a goal. If your goal used to be find something in a 1D array and you've changed your goal to find something in a 2D array, you go from having a single for loop to a nested for loop. And then the rest of the algorithm is basically the same. Add up all the items, find the average, those are all the same. So 2D arrays, not too bad. Just really don't get screwed up on the indices. Indices is plural of index, by the way. So just don't get screwed up on the indices and you'll be good to go. It's also kind of fun because I'm going a little faster towards the end of these review items for the units that you did more recently in class, because you probably just did this a couple weeks ago. So you're feeling good on 2D arrays. It's not so bad. Same as arrays. No big deal. You can do a 2D array list. That's crazy. They're not going to ask you to do that. 99% sure. Okay, that's 2D arrays for you. Okay, inheritance is not something where I'm going to dive too much into the code. I want to dive into the concepts and the concept and the vocab. Okay, so without drawing a diagram too much, there is a general thing like a vehicle. And then there are specific types of vehicles like cars and motorcycles. That's what inheritance is. So the superclass, the parent class, is the vehicle, which is a general type of thing. A car is a child class or a subclass. A motorcycle is a child class or a subclass. So many of the things that you can do with a car, you can also do with a vehicle. But like motorcycles and cars are different, but they're both vehicles. They're both ways that you can get from point A to point B, but a motorcycle has 2 wheels and a car has 4 wheels. So like that's just like in general what's going on. Yeah. So a car is a vehicle. This is inheritance. A motorcycle is a vehicle. This is inheritance. A car has a wheel. That is not inheritance. That is just describing an attribute of a car. Okay. The super class is more generalized. The subclass is more specialized. So you also you all did this in 9th grade geometry, or whatever year you took geometry, 10th grade. I don't know. There's shapes and triangles and a quadrilateral and a square. So here's an example. All shapes have sides. Triangles have sides. A triangle is a shape. A quadrilateral has 4 sides. It is a shape. A square is a quadrilateral. So we could say this. A square is a quadrilateral and a quadrilateral is a shape. So a square is a shape. A square is not a triangle and a quadrilateral is not a triangle. Not all shapes are quadrilaterals. Not all quadrilaterals are squares. A square is a very specific type of shape. A triangle can come in all shapes and sizes. Okay, so this is where just like the syntax becomes very annoying. You put the superclass to the right. So an employee extends person. So it's like, what does this mean? A person is a very general thing. An employee extends it in that an employee has more specific things about it than a person. The first call of any constructor for a subclass has the super. This calls the person constructor. And then if you have multiple constructors with multiple amounts of formal parameters, you can also call specific constructors with different formal signatures using the super keyword as well. Okay, so you can override methods. So what does that mean? You as the specific, if you have a superclass, it can do something very general, and then the subclass can do something more specific. So we have this really stupid example. I can make it bigger. We have a greeter class. This is the superclass. The method greet says the word hi. We have a class called mean greeter, which extends greeter. And the greet method says go away. So these are both like a mean greeter, an object of type mean greeter is of type greeter. So you can actually declare it like this. You can say that the mean greeter is of type greeter, and you can do g2.greet, g1.greet. So while they both have the same type in some sense, in that they both are they both are instances of the greeter class, More specifically, this G2 is an instance of the mean greeter class. And so when you call the greet method, it does the thing defined in the mean greeter class. Okay, so overloaded methods. Overriding is a super class and a subclass having the same method. Overloading is when in the same class you have two methods with the same name, but they have different signatures, different parameters. The super keyword, again, as described above or earlier, you can use a super class's method in a subclass by calling the super keyword. Shout out to CS Awesome for this diagram. Here's another, and so here's a word for you: inheritance hierarchy, inheritance diagram, class diagram. There's a thing called UML. I don't know what that means, but I forget. But you have a diagram like this. So a square is a rectangle is a shape. So if you declare this in Java, it would be public class rectangle extends shape. Public class square extends rectangle. Nice. Fun fact, you can have an array of shapes, and one of them can be a rectangle, one of them can be a square, one of them can be a circle. And so to some extent, this makes sense. It's like a logical thing that makes sense, right? I have to, if I want a list of shapes, I declare a list of shapes, and then inside of them, anything that is a shape can go in that list. That's what inheritance is all about. It's not like, there's a lot of vocab, but it kind of makes sense. It's not that complicated. Object is the superclass of all Java classes. Fun fact. Objects have the method toString and equals. There's a bunch of vocab. All right, well, so that was inheritance very briefly. Again, it's more about the concept, and then you do need to kind of know this syntax, of course. But as long as you get the concept, you know the super keyword, and you can think about these sorts of situations here in terms of what will happen. Like, you will get multiple choice questions where they define a class and they define a subclass. So there's a superclass and a subclass, and then they call a method on the subclass, and you need to do the whole inheritance thing. But as long as you get the kind of general idea of what's going on, you should be in decent shape. Again, this isn't a deep dive. This is more for you to review the overall concepts. So that's that for inheritance. Okay, you made it this far. Here's my dog. Dog, you want to say anything about APCSA? He doesn't. Bye, dog. All right. Unit 10, recursion. We're here. Final chapter. Let's get it going. Okay. So recursion is, wow. I got a little unhinged when I was making these slides. Recursion is when a method calls itself. Be careful with recursion because you'll probably do it wrong. Recursion is an alternate way of doing a loop. These are all true statements. Okay. So here is a countdown example. So countdown, we call this, if we call countdown with the parameter 5, give me a second, this dog needs to unpaused. Okay, so if you call countdown with the parameter 5, you'll see that countdown calls countdown of 4, countdown of 4 calls countdown of 3, countdown of 3 calls countdown of 2, countdown of 2 calls countdown of 1, countdown of 1 calls countdown of 0, countdown of 0 calls nothing. Just said a lot of words, but this is recursion in a nutshell. So recursion is an alternate way to do a loop, and you call the method, and the method calls itself. And so it does this thing where it's calling itself. But in order for this to not happen infinitely, similar to when we first discussed while loops like an hour ago, you need to have some condition, and you need to have something about the condition changing. So when this is called the recursive call to the method. When you do this, you have to change the value of the thing. Like, you can't just do countdown and num times, because then it'd be countdown of 5, 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 countdown of 5. Should I keep going? No, I should not. So that's what would happen with recursion if you never changed
the value getting passed to the method when you're calling itself. So yeah, there's that. And then you also need this condition. This condition is called the base case. Okay, so maybe we have another example. Or here's just the definition. The recursive case is the part of the recursive method that calls the method itself. The base case is the part of the recursive function that does not call itself. This is me. This is my editorial. If I was going to write a recursive method, which you don't have to do on the AP exam, the first thing you would do is write the base case. Now, what you do need to do on the CSA exam is analyze a recursive method. So this is a very classic example. In math, there's a thing called factorial. It's factorial of 5 is 5 times 4 times 3 times 2 times 1. That's a thing that exists. It's very important, but you don't need to know about it for the AP CSA exam. But on a multiple choice question, if it says we called factorial of 4, you might need to trace the code and figure out what happened. And this is what happens. And so you see the base case, and then you see the recursive case. That's literally it. So thank you very much for watching this video where we went through and we reviewed every chapter in CSA. This is for 2020. This video will need to be updated for 2025. So if you're watching in 2025, or it's 2025 right now, this is for the 2024-2025 school year for the exam taking place in May of 2025. If you are here in 2026 in the future, you need a slightly different video. Things have changed around a little bit, and they might not even do some of this stuff, and there's going to be different chapters. So a lot of this applied, but some of it didn't. So just FYI, be careful if you're coming from the future. Hopefully I posted a new video then. Anyways, thank you for watching. This is all I got to say. I'm going to go edit this video and post it.